Yeah. Hi, Karthik.
Yeah, Santosh. Able to hear me.
Okay, fine. So let's start. So quick summary. We completed the logistic regression code, sorry, theory, code, and few extra stuff like hyperparameters and assumptions. Okay. So I hope you are good with logistic regression concept. Basically, code is not a big deal as of now, but so can you say you are good with logistic regression background concepts, Karthik?
Yeah, Santosh.
Okay, fine. So now let's start with, as I was saying yesterday, let's start with a concept called as classification metrics. Okay, so now this is one of the very important concept I would say. So which is independent of any model. So it applies to all classification models. Okay, so now basically what is metrics? Like it is a way of calculating or finding out how good or how bad a model is, right? So just like how we had different kinds of metrics in regression, right? So for example, if you see in regression, we had MAE, MSC, RMSC, okay, different kinds of errors, basically errors. And from that, we have deduced some scores called as R square, then we have adjusted R square. Okay. These are,
Yes.
but by using this only, you can know how well your line is fitting or how bad your line is fitting, how much it is able to explain, correct? Because using all the training stuff till the gradient descent part, fine, you got a model in the sense, in this we got line, okay, but that line is 100 not 100% perfect right all the time. Most of the time it's not 100% perfect because it is not going to go pass through all the points, it is going to do some mistakes. So obvious, if it is 100% every time, so there is no need of any metrics. Agree?
True.
Because
True.
directly you will say it is 100%. But most of the time it will not be 100% perfect. And we don't want it to be 100% perfect. Because why? Again, we will face the problems of overfitting. Correct?
Yes. Yes.
Right. So that's why we need to tell like how good. Like, is it okay? It's not 100, but is it 80 or 90? What about the remaining 10 where it is failing? Okay, that kind of stuff we have seen in regression. Same concept, okay, but now this is for the classification part. Okay, so this is going to be interesting. Okay, so now let's start. There are very many new things we are going to learn today because the whole concept of classification metric has many components. Okay, so and let's see how much we can cover in today's class. Fine. Fine. So let's start with accuracy because this is the first thing I think you might have hearing like whenever we are seeing any code, right? For example, yesterday also in logistic regression,
Yes,
we
accuracy.
we saw accuracy.
Correct means yeah. Yes.
Okay, so we got 83.9. Okay, fine. And in some other example also, we have seen accuracy, some 73. Okay, and accuracy is a common word, right? Even in general life also, day-to-day life also, we'll say how accurate is this or how accurate is this news, right? In different contexts we use. Okay, so you're familiar, right? We are familiar with this word. But in machine learning, so this has, we'll see in some more depth. Okay, we'll see how good or how bad is this accuracy. Okay, but first of all, if you see the Wikipedia definition of accuracy, what is it is, it is in machine learning, accuracy refers to the proportion of correct predictions a model makes out of total number of predictions. Okay, it's a fundamental metric for evaluating classification model performance, indicating how well the model distinguishes between different classes. Okay, a long definition. Okay, don't get worried if you don't understand. The basic point is, it is saying accuracy is the proportion of correct predictions out of total number of predictions. Okay, that means how many predictions does the model has made, right? So that means how many test records you have passed, correct? So how many test records you pass, those many predictions you will get. Simple. That means if there are 800 total data sets, oh sorry, yeah, if there are total 800, so in that, let's say you are having 700 training and 100 test, fine. So now first you will pass this all this 100 into for prediction. Training is done. While testing, you will pass these 100 rows to get predictions from the model, correct? So that means what? The model is generating 100 predictions. Agree?
Yes.
Right? But out of this 100, how many are correct? How many are wrong? We don't know. Correct? No guarantee that
True.
all this 100 will be perfect, right? So it is just saying, so let's say you are having out of this 100, 80 are perfect, for example. So it is saying what the proportion of correct predictions a model makes out of the total number of predictions. Okay, so now here it is 80.
Okay.
Okay,
80%. Yeah.
that's fine. But are we good with this 80? No. Okay, so we will see here. But there is one fundamental concept, okay, in this classification matrix, Karthik, which is called as confusion matrix. Okay, the name itself is
Okay.
confusion matrix, but it is not at all confusing. Okay, but it is a very, very fundamental concept. But because whatever you are going to study, the whole classification matrix, for that matter, any other matrix you are going to see is only dependent on this. Okay, so if you understand this, if you have clarity on this, it's a very simple concept. Okay, but if you understand it very clearly without confusion, from this itself, we are going to study all remaining concepts. Okay, we are going to see different concepts like let's say precision, recall, F1 score, ROC, AUC, all concepts in whichever source. Okay, after this class, any article you open or any video you see, okay, fundamentally, if you understand this confusion matrix, okay, then you'll be able to understand anything. Okay, you'll
Okay.
have a very good picture. Okay, first let's try to understand confusion matrix very clearly. It's very simple concept. What does it say is it is a matrix. Okay, now what is and it is a square matrix usually. That means 2 cross 2 or 3 cross 3, and this is depending upon your number of rows.
Okay.
Okay, not rows, sorry, classes, output classes. Okay, yes or no? Two classes,
Yes, 2 classes, 0 and 1.
0 and 1. So number of classes, 2 classes. Fraud or not fraud, 2 classes.
Yes.
Okay, but let's say which party is going to win? Congress, BJP, BRS.
There
3
are
classes.
many.
So then
Yes.
in that case, it will be 3 cross 3.
Yeah, 3 by 3.
Okay. So, but to understand all the concepts, we'll first focus on binary and then we'll see how you can easily extend this to multi-class also. Okay.
Okay.
So now usually for binary, that means what? Yes or no, pass or fail, spam or not spam. Okay. Cancer or not cancer, this kind of stuff. Fine. So in that case, you are having 2 classes, 0 and 1. So then your confusion matrix will have 2 by 2. Now, if you see here, what it is saying is very simple. You are going to have a matrix. Okay. These are actual values. That means what? Wherever the actual label is 0. Okay. That means what? These values. Okay. So if I just put a 1 second filter. Okay. So wherever you are having 0, these are the 550 are rows with 0 label.
Yeah.
Agree?
Yeah.
And remaining, these are the 1 labels.
Yeah.
Okay. So whatever you are seeing is that means 0 label classes, 1 label classes.
Yes.
Similarly, these are 2 outcomes from the actual data set.
True.
Correct. Now this is predicted side. This
Yeah,
is
even predicted
actual
also 0 and
data
1.
side. This is predicted. In
Hmm.
predicted also you'll have only 2,
Yes.
0 and 1. It cannot predict anything because whatever it is trained, it will predict only those.
True.
Now, you already know, just now when I was saying here, when the model is, what does basic accuracy mean? That means you are passing 100 data set. Okay, that means model is giving 100 predictions. Whether
Correct.
they're correct or not, we don't know. So here, let's say if you're assuming 80% correct, that means remaining 20% it has predicted wrong.
Yes.
But wrong in the sense what? See, correct will have only one definition. That means 0, if you give 0, you will get 0, that is correct. No other way. If you give 1, you are getting 1, that is correct.
True.
But wrong is what? If you get 0, whether you are getting 0 or if you get 1 when you are passing 0, that is also wrong.
Also 1, it is getting 0, that is also wrong.
That is also wrong. So what I'm saying here is, for correct, you don't need to ask which type of correct it is, because when the input is equal to output, that is correct. We are fine.
True.
But for wrong, we need to know which type of wrong it is.
Correct.
Correct? Yeah. So exactly. So here what it is saying is, so for example, here, for example, 0 and 1. So this class, 0 class, if you consider it as negative class, usually we consider it as negative, positive, one will be negative, one will be positive. Usually one will take it as positive. Okay? This is negative class. This is
Means, mean, for example, yeah, it's out of context. For example, if insurance either approved or rejected, approved we
correct.
will consider as one, or rejected will consider zero, or zero is for approved, or
Yeah,
rejected is for zero. How it will be in general terms
yeah.
in our
So
project is?
yeah. So for example, you are having spam.
Mm-hmm.
Yes, it is spam. That is one.
Mm-hmm.
No, it is not spam. That is zero. Okay.
Okay, yeah.
Approved. Okay. Your
Spam.
loan is approved.
Mm-hmm.
Yes. Yes is one.
Okay.
No, it is not approved.
So
That is
whatever it is comes under yes, okay, that
yes.
will be. So irrespective
Okay.
of,
Correct.
okay, fine.
Correct. Okay.
Okay.
Now, if you take, yeah, so this is spam. Now, over here, you are having 0 and 1. Okay. 0 and 1.
Mm-hmm.
Now, if you see here, what it is saying, so these values are very, very important. We are having TN, okay,
TP.
FP,
Okay.
or let's say TN, TP, FP, FN.
Mm-hmm.
Okay. These are called as true negative, true positive,
Okay.
false positive, false negative.
Okay, got it.
Okay. So I will just show you here, same picture, but expanded, actual, predicted. Okay. So this 0 and 1 you can take anywhere. Okay. There is no room
Mm-hmm.
for 0 next one. Okay. Here I'm taking 1 and 0, for example, you see. But whatever order you are taking here, you should use the same order here.
Correct, correct, correct.
Okay. 0 1 0 1. Okay. Or 1 0 1 0. Okay. Fine.
Got it.
So over here, now if you see, this is true positive,
True.
sorry, false negative, false positive, true negative. Okay.
Mm-hmm.
Now, what are these? Okay. These you need to understand. First is, that means what? Very simple. Okay. This picture you should always have in your mind. Okay. This diagram. So now, what is this true positive? That means you are passing in 1. See, actual is 1. Model is saying is also 1.
Yes.
Okay. True positive.
Correct.
You are passing 0. Model is also saying 0.
Hmm. True
True.
negative.
Okay. Here, you are passing 0.
Model
But
is
model
giving.
is saying 1.
Yeah.
False positive.
Okay.
Okay. And here you are passing 1, but model is saying 0. Okay. False negative.
Hmm.
Right. So true positive, true negative, this will be diagonal.
Yeah.
Okay. This will be false positive, false negative. But don't get confused, like which will be positive, negative. So here you can, one way people usually get confused. They might think that this is positive, this is negative. Okay. One way you need to
Okay.
understand here is, see, this P is there, right?
Yeah.
The second one, that is positive.
Hmm.
That means from the
Mm-hmm.
model,
Correct.
model prediction is positive.
Yeah.
Okay, see here, try to understand. This is 1. 1 is what?
Correct.
Positive.
Positive.
But what one is this? Is this prediction positive or actual positive?
Prediction.
Okay, so that means these two are prediction
Comes
positives.
under prediction. Yes.
So that's why you are having P, here also P.
Yes. Yes.
So,
Yes.
but this is positive. Prediction is positive. But whether the
Hmm.
actual is positive or not, here,
Yes. Positive.
yeah, prediction is positive, actual is also positive. That's why it is true positive.
Correct. Correct.
Okay, here also it is prediction positive, but is the actual value also positive?
No. Zero.
No, 0. That's why it is false positive. It is a positive,
Correct.
but it is false positive.
Correct. Correct. Got it.
Correct?
Understand. Yeah.
Clear, right? Same thing.
Yeah. Yeah.
Here also, these both are negative,
Hmm.
negative predictions.
Yes.
Okay. But here, if you see, this is negative and it is true negative. Why?
Input
Because
is also
model is
negative.
also saying 0. Sorry, actual is
True.
also 0, model is also saying 0. So it's a negative,
Yeah.
but it's a true negative.
Yeah.
Here it is negative, but actually is the model is actually negative. No, it is positive.
Correct.
Correct. So that's why it's a negative, but false negative.
Correct.
Okay. Correct. So this TP, TN, FP, FN, we call TP, TN, FP, FN.
Hmm.
Okay. These 4 fundamentals you should be clear. Okay.
Okay.
So if you get confused, FN means what? N is negative. That means prediction is negative. But why
Actually,
it's calling
false.
false? Because
False.
the
Actually, is positive.
yeah, actually is positive.
Yeah.
Okay. So
Hmm.
now what does this fine? So now confusion matrix is a matrix over here. So it is saying so these will have values.
Hmm.
Okay, that means what? Out of 100, for example, you are saying 100 rows I am passing in.
80 rows sir comes under TNTP.
Correct. Perfect. So when you are saying true positive, true negative. That means what are the correct predictions from the model? So those are T and TP.
Yeah.
Combination of this Tn plus TP
Yes.
is going to be 80. Okay. So that means what in what all cases when you're passing 0 and the model is also giving 0, those will be under Tn. Correct. So wherever you are passing all these rows, okay, you are passing how many 550 rows. In these 550 rows, you are passing. From this, how many of them the model is also predicting 0? Those
Yeah.
are Tn. Okay. Or in the other way, for example, if you see TP, usually this is most followed. Okay. 1010 TP, Tn, FP, Fn. Okay. So how many cases when you are passing 1 and model is also giving 1? So that is TP.
Yeah.
How many pass you are passing 0, model also giving 0? That is Tn. Okay.
Okay.
How many? That means, see over here, when you are passing 1, I'm saying how in total number of 1 you are passing, how many of that model is also giving 1? That means, for example, if you are passing 50 and for that 50 ones, model is giving only 40 ones. That means remaining 10 model is giving 0, right? Sorry. Yeah, correct. See,
True.
you are passing 50 ones. Okay, you are passing 50 ones you are passing. In that 50, see, when I say you are passing 50 ones means what? You are passing 50 rows where the label is 1. You are getting right my terminology.
Correct. Yeah.
In
Understood.
that model is saying model for 40 rows, model is saying 1.
Model is also predicted
So this
one.
is, yeah,
Yeah.
this will come. So this 40 will come under as TP.
True positive. Yes.
But remaining
Remaining 10
40
comes
also, remaining 40, the model is not giving 1, means it is giving 0 because there are only two chances, 1 or not
Yes.
0.
Yes.
That means here what is the case? You are giving 1.
Correct.
40 went to 1, but 10 went to 0. So this 40 will become TP, 1 TP. So here this will go to, you are giving 1, but output is 0.
Correct.
So output is 0 means what? 0 is negative, that means N, but it is false 0.
Correct. False negative.
Okay, the 1 0 is Fn. So 1 0 is Fn.
Correct.
Okay, so your TP will be 40. So this value will be 40. Okay,
False negative
this
0.
will be
Same.
10. Okay, and remaining, for example, if you are getting accuracy as 80, so TP plus TN should be 80. So this is 40. This will be 40. And
And here
remaining, for example,
10.
100, overall 100. Okay, so this. That means what? 40 rows you sent 1, model gave 1. For 40 rows which are actual 0, model gave 0. But for 10 rows where actually it is 0, the model is saying 1.
Correct.
For remaining ones, model is saying 0.
Yes.
Okay. So only these 4 combinations are possible, right? 1 0
Yes.
0 1 0 0 1 0. Same thing when we saw over here, if you remember this case, actual predictor 1 0 0 0 0 1 1 minus 1.
Correct.
Okay. So this should be 1 1. Sorry. Okay. 1 1 0 0 1 0 0 1. Fine. So this actually we have, for example, I will just quickly show you how you can get this. For example, when you say, just like how you are taking accuracy score and passing test and, for example, if you see here, accuracy score, you are passing test and prediction, right? You are getting this accuracy. Same thing, you can import the confusion matrix this way. Okay. For example, if you see here, from sklearn.metrics, you are importing accuracy score till now. Similarly, you can import something called as confusion matrix.
Okay.
Okay, and it is simple. So how you are passing these both the values to accuracy score, same thing for the confusion matrix also you will pass to y-test, y-pred.
Okay, got it.
Okay, so this is the matrix it is showing.
Yeah, 36
Right?
are true positive and 29 are
36,
true negative.
13, 11, 29.
29.
Okay, and here, for example, here if you see, these are the classes it is giving 0 and 1. Okay, this is 1. Okay, this is 0, this is 1. So 0 0, this is
true negative.
true negative. Okay, this is true positive.
Correct.
And this is positive but false positive. This is negative but false negative.
Correct.
Okay. Based upon the classes. So it is telling what classes it is giving. 0 and 1 it is giving. So this is 0, 1, 0, 1. Okay.
Yes.
Yeah. So now with this, from this matrix only, you can calculate so many values. Okay. The first thing is accuracy. So accuracy is what, as you have just said. So this is just a total number of predictions. correct predictions. So what are
Correct.
correct? Only TN and TP are correct.
Correct.
What are total? All these four are total. Okay. So that's why if you see, accuracy is TP plus TN by all TP, TN, FP, FN.
True.
Correct? That is a same thing. So predicted actuals TP plus TN, okay, these two by TP, TN, FP, FN. That is accuracy. But you understood confusion matrix?
Yes, sir.
Okay, fine. So now when it is performing correctly, there is no problem. But it is when it is performing wrongly, that is a problem. Okay.
Correct.
So now we will see which cases like FN is better or FP, or in which case FP is better or greater than FN. Okay. So we'll see because it is doing error.
Mhm.
Okay. But which type of error it is doing, that is also important. Okay.
Okay.
For example, I will ask you simple thing. You can tell me. You are building one small classification model. Okay. And the model work is spam. Okay. To classify spam.
Yeah.
Okay. So what are the cases? Spam, not spam.
Correct.
Okay. So if it is spam, yes, it is spam. Okay. Sorry, I'm saying this way. So for example, you are having this box matrix. Okay. Spam, not spam. So for spam, I'm saying 1, not spam is 0. Okay.
Okay.
This is also same spam, not spam. Okay. But I'm not writing here, but I'll just saying
Yeah,
1.
yeah.
So spam, this positive I'm saying. So this will become TP.
Mhm.
This will become TN.
Yeah.
And this is 0. That means it will become N, FN.
Negative.
And this is
False negative.
positive. It is positive, but it is a false positive. Okay. Perfect.
Yeah.
But now just tell me, Karthik, so you are building a spam. Okay. When it is spam, if it is you have folder, right? So even in Google you will have spam, Gmail you will have
Yeah,
spam.
yeah.
Okay. So but we never gave any rules or we never gave any algorithm to Google, right? So classify it is automatically doing. That means some model is running behind.
Correct.
Correct? So you know the spam mails like you won a lottery
Yeah,
or
yeah.
this offer, Myntra offer, okay, or some price.
Correct.
All those are spam mails. Okay, that those are automatically going into spam folder. Remaining important mails they are passing to input
Primary.
inbox or primary. Okay.
Hmm.
So now just tell me if a spam is going to spam, perfect.
Hmm.
If a non-spam is going to not a spam, that is also perfect. Now,
Hmm.
there are two errors. If a spam going to not spam, a not spam going to spam.
Correct.
Two cases, can you just think and tell me which is more dangerous?
Not spam going to spam folder is dangerous because if spam going to the primary folder, at least we can see whether it is useful or not. Otherwise, we can delete. Otherwise, if it is, normal mail going to the spam, that is dangerous because it will automatically delete, or we will delete by clicking without checking anything.
Perfect. Correct. Exactly. So here, if you see this FP, it is not a spam,
Correct.
but it is going into spam. Prediction is spam.
Hmm.
That actual it is no 0 means not a spam. Okay, this is not spam, no going to spam. Correct. But here it is FN. That means it is spam going to not spam. Okay, here spam
Hmm.
going to inbox, for example.
Yeah.
Okay. So in this case, if you see which is more dangerous, can you tell me?
The below one, 0 to 1,
No,
not
no.
FP,
From now on,
FP,
just
FP,
correct. Tell me like that. Which one?
FP,
FP.
false positive. Yeah.
Okay. So FP is more dangerous. Okay.
Correct.
And one thing you remember here, TP, TN are truth values.
Correct.
FP, FN are error values.
Correct.
You always want to have high values for TP and TN,
Correct.
low values for FP and FN because error values.
Correct. Correct.
And always the sum of all these values is equal to your
100.
data
Our
set,
data
the
point.
number of rows you
Data
are
point.
passing.
Yes.
Okay. Means for test data set also you can pass, for training also you can pass. Test accuracy,
Yeah.
training accuracy, right? So for example,
Yeah.
usually when you pass testing data set, 100 rows if you're passing, so this 100 will be distributed among these 4, but ultimately
Correct.
the sum will be 100.
Correct.
Correct? Provided you are getting predictions for all the,
Yeah. Yeah.
okay? That means
Yeah.
simply these are like 4 levels, right? Bar diagram. So if one is increased, other
Correct.
decrease.
Correct.
So that the sum will be same. So okay, it's just
Correct.
like game. Like so, if you want to decrease FP, some other thing is increasing.
Correct.
So the goal is to decrease these two such that these two will increase.
Correct.
There is some trade-off between this.
Hmm.
Fine. So now, yeah, as you're saying, now FP is more dangerous. That means what? We want FP should be less than FN.
Less. Correct.
Okay. So that means what? Okay. Ideal case, best case is FP equal to FN equal to 0.
Correct.
Correct? That means no errors. Everything is perfect. Perfect classification. Ideal case, happy. But usually there will be some sort of error. Okay. The model might not be 100% perfect. Correct?
Yeah.
So in that case, they obviously that means you should take some error. But which type of
Hmm.
error are you okay to take? I want to take FN error in this case. Okay,
Correct.
it's very, very domain
Correct.
specific. Okay, you cannot directly
Yes.
say which is better without knowing the domain background. Okay, so in this
Correct.
case,
Correct. Correct.
I want FP should be less than FN. Okay, because FN I'm okay. If a spam is coming to inbox, that's fine. I will see and I will delete. But if a offer letter or if something in my medical report, okay, is going into spam, that is more dangerous.
True.
Correct. So in this
True.
case, low FP. Okay. Oh, in this case, FN is better than FP. That right? FN. If you FN is
Hmm.
better than FP in this case.
Yeah.
Okay. Now, for example, if you see same case, okay, if you tell me, okay, you are having a patient, a doctor has started diagnosing cancer. Okay.
Hmm.
So he's having cancer. Yes, cancer, no. Okay.
Hmm.
Cancer, yes, cancer, no. Okay. So same thing, TP, TN, FP, FN. FN, FP. So now again, can you just tell me, is this also the same case? Like, which is more dangerous? Like, if a cancer patient, if the model is saying no cancer, is that better, or no cancer saying yes cancer, is that better?
If a cancer person, if report is showing like prediction is showing, if cancer person has no cancer, then he will not get into the treatment. That is dangerous.
Correct. But whatever the other case, even if it is not having cancer, if I say cancer,
At least he will go back and check again. In that case, I mean, we will retest that.
perfect,
So though that is not a I mean big deal compared to first one.
perfect, perfect. Okay, exactly. So here TP, TN anyhow it's perfect. Okay. So here FP is what? FP means he's not having cancer, but model is saying cancer.
Yeah.
Okay. No cancer, but doctor is saying yes cancer. But here FN is what? Actual it is 1. That means yes, he's having cancer. But
Okay. Yeah.
model is saying no, not a cancer. That means doctor is saying.
Yeah.
Okay. So here in this case, which is more harmful? FN or
Uh,
FP?
1-0. Yeah. FN is more harmful.
Correct. FN is more harmful.
Yeah.
Okay. Then FP. So that means what? We want less values or high values of FN.
Be less. FN should be less.
Okay. So FN should be less than FP. That means FP is better in this case. Okay.
Correct.
FP is better in this case. That
Correct.
means he's having not having cancer. If you say okay, then he's having cancer. That is better still.
Correct. Correct.
Go and
Yeah.
or he'll
Still
go to some
better. At least.
yeah he'll go to some
Yes.
other doctor or he will go for further test etc.
Yes.
Okay. So that's why as I said FP or FN which is better that is very very domain specific. Okay. But just small tip is usually in health related or life related domains, right? So there FN
Hmm.
is more dangerous.
Correct. Correct. Insurance approved or rejected, whatever.
Correct.
Yes.
Correct. Okay. In those cases FN is there and remaining other cases FP is a bit dangerous. Okay. Clear
Yeah.
confusion matrix FP FN TPTN.
Yes. Yes.
Okay. Now with this understanding we'll again see what is the problem with accuracy. Okay. So when we are saying there are okay, so when we were saying here 80% accuracy, where it is, yeah. So for example, if you see 83.9,
Mm-hmm.
okay, that means almost 84%. 84 is not a bad accuracy, it's a good accuracy.
Okay.
Okay, but can we deploy this model? No, that is a problem with accuracy. The fundamental
Okay.
problem with accuracy here is it is saying 84% it is doing correct predictions. Correct? Out of, if you consider 100% of input data, that means test data set,
Correct.
in that 84% is working. But what about the remaining 16%? Correct? In the 16%,
Yes.
what type of error it is doing? How many FP or how many FN?
FN. Yeah.
In this 16%, for example, if it is cancer related data where FN is
Or
dangerous, for example, in this 16, if 15% of the time, if it is falling here only 1%, that
it's
means
dangerous.
big failure.
Correct.
Correct? Because in this, not 15, forget about 15, even if for example, even if it is 1% also and 15 also, it is also still dangerous, because
True.
it is
True.
related to life. 1% means, for example, 1,000 patients, 1% means how many? 10 people.
True. 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 Then
10 people life we are putting in risk. We don't know, it might.
correct.
Okay,
Correct.
in the 10 people you are saying no, not a cancer, most of them they will ignore, right?
Yes. Yes.
Might
Yes.
go to
Yes.
severe stages. Fine. So in these cases, even if 1% is also, it's very, very, even one patient also, it is going to be very, okay, crucial.
Correct.
Correct? So, but the problem with accuracy is, just by 84, it might give you a false perception that, okay, the model is perfect, but behind that, we are not sure like how bad the model is performing in these areas. Correct? So that's why where the model is working well, that is important, but more than that, where the model is not working well, that is also important.
Correct. Correct.
Correct?
True.
So
True.
that you will know by using this TP and FP and FN, and this you are going to get it from the confusion matrix.
Okay.
Okay. So actually everything you are going to get from confusion matrix itself. Okay. That's why it is the fundamental concept over here.
Okay.
Right. Right. So and other case also, for example, accuracy also not 83. Even if you have 90% or 99% also, sometimes it's not good. Okay. Because for example,
True. True.
cancer case we are saying, and also self-driving case. Okay. In self-driving case also, so for example, see, we have Tesla cars, right? So in Tesla cars, it is almost automatic cars. So
Correct.
it drives by itself on main roads, highways, and usually what happens, for example, if you have a street light, so initially it will take that image. Okay, it will capture, the sensors or cameras will capture the image, and then it will classify based upon
Correct.
its algorithm, behind the algorithm. Of course, it will use latest
Correct.
technologies, but for example, the fundamental task is classification. So it will, based upon its training, it will classify that image, whether it is
Correct.
pole or a signal, traffic signal, or some stick or etc. Okay, because it's a very long, tall object. So now
Correct.
when it is classified, but now if the classification is as per its result, if it says it's a traffic signal, okay, then it will stop based upon that. If it is a pole, it need to take a right turn or left turn, something like that. Fine. So now, instead of, if it is classifying wrongly, that means instead of taking
Yeah. Yeah.
pole,
We
okay,
have.
instead of pole,
Yeah.
if
We
it is
saw that.
taking traffic signal, it will unnecessarily stop.
True. True.
Because-
We saw that actually earlier. Like
Hmm.
even Tesla recognized the sun as a traffic, so it got slowly moved. I mean, yellow light
Yeah.
signal.
Like in the highway, right? In the far
Yeah. Yeah.
distance,
Highway. Yes.
it's
Yes. Yes.
thinking the sun as a traffic.
Yes.
Yeah.
Yes. Yeah.
Right. So it is, yeah. So there, even if the accuracy 99% of the time it is working fine, but even if one time it is not working fine, okay,
Yeah.
1%, fine. So that might cost some lives, right? So that's
True.
why 90 or 95% accuracy looks good, but it is not actually good. Okay. So the fundamental problem here is, when you're saying 90% accuracy, means it could be 10% error. But the problem is, just by looking, we cannot directly conclude which type of error it is. Okay. It could be FN error or it could be FP error.
Okay.
Okay. Now, yeah. So over here, if you see, same thing, we are having actual, predicted, okay, spam, not spam. So these are the values, how it will look like.
Yeah.
So true positive 600, 9,000 are true negative. Okay. Whether
Yeah.
it is true negative, we are happy. Okay. But false positives are 100 and false negatives are 300. Okay. Fine. So over here, next we have something called as type 1, type 2 errors. Okay, there are errors, but these are classified into, they give separate names, type 1, type 2 error. Okay. Nothing new, just one new thing is, false positives are also called as type 1 error.
Yeah.
False negatives are just called as type 2 error. Just new name, that's it.
Okay.
Okay. So usually
Yeah.
instead of asking how many false negatives, they say,
Type 1, type.
hey,
Okay.
what is type 2 error?
Okay.
Okay, what is type 1 error? Or which type of error is more dangerous in this domain? Okay. In cancer case, type false negatives are more dangerous. Okay. And usually, not 100%, but usually they'll say false negatives or type 2 errors are more, okay, dangerous errors.
So we'll consider always which one, 1 1 1 0 or 1 0 in such a, I mean, a
So
matrix.
here it is positive. Here it is positive, right?
Yeah. Earlier model showed us like 0 0 in such a way. So what is the exactly we will consider matrix? It starts with 1 0 or 0 1.
Yeah, it is true. See,
True only. Always
spam.
first.
Yeah, spam. See, in your case, spam. Spam
Hmm.
is, yeah, yes, it is spam. True. Yeah, that will become true. No, it is not a spam.
Okay.
Cancer.
Okay.
Yes, it
Okay.
is a cancer. That is true.
Okay. Okay.
No.
Yeah. Okay.
Loan.
Because
Loan. Is
because
it?
always if someone asks type what is type 2, directly we will consider okay, it's a false negative case.
Yeah,
Type 2
type
error.
2. Yeah, correct, correct. So type 1, type 2 are not related to how you are considering. Wherever you are considering, FN, false negative
Hmm, hmm, hmm.
is type 2 error.
Okay.
False positive is type 1 error.
Okay.
Okay,
Yeah. Yeah.
fine. So that is one case. And that is one problem of, accuracy. Okay,
Yes.
where,
Yes.
and second thing is accuracy a
Could
problem
be missing.
will occur when you are having imbalanced data sets. Okay,
Okay.
that means what? If your input data set is having imbalanced number of labels, not labels, the count of rows with output
Mm-hmm.
labels. That means over here you are having how many? Okay, 550 ones are there, and
Yeah.
sorry, and 550 zeros and 343 ones. Okay,
One.
out of 800, roughly
Mhm.
500 are zeros and 300 are ones.
One.
This is okay. They should not be equal, but these are balanced. That means at least the model is getting exposed to 300 of ones and 300 of zeros and plus 200, extra 200 of zeros. Okay, that's fine. But in some cases, for example, you have only 10
Mm-hmm.
ones and 8, sorry, was 790 zeros.
Mm-hmm.
Okay.
Okay.
In that
Mm-hmm.
case, this could be problem. Why? Because,
Okay.
for example, fraud rows are there. Okay, wherever you are having one that is fraud, wherever you
Okay.
that case, in a data set, the data set related to
Mm-hmm.
fraud or not fraud. Okay, so wherever you are
Okay.
having one that is fraud
Okay.
transaction, be a transaction for transaction. Wherever you're having
Uh,
zero, that is per
Not
normal.
a fraud transaction. Yeah.
Okay, in one day, if you take how many
Mm-hmm.
transactions you will make, let's say 1 billion.
True. 1 billion.
This 1
Maybe.
billion, I don't think even 1% will be fraud.
Hmm.
Okay, for example, let's take simplicity, one lakh transactions in
Mm-hmm.
1 hour. Okay, just consider
Mm-hmm.
1 hour data set.
Mm-hmm.
1 lakh
Mm-hmm.
transactions has happened. In this, 1% is how much? 10,000
10,000.
or 1,000. Uh,
1%, right?
yeah. So I think it is 1,000. But
1,000.
10,000, right? Okay.
Yeah.
So, but I don't think there will be 1,000 fraud transactions. Okay, the count will be very very less. 10
Yeah.
fraud. Okay, max
Mm-hmm.
in an hour. Right? But those are dangerous. Even one fraud transaction could be like
Yes, we
50,000.
should not do. Yeah. 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 Yeah.
Correct. So, but the count will be less. Correct.
Correct.
So let's say 10 fraud transactions. So if you see the label data set, so wherever you are having perfect transactions over here, like 9 lakhs,
Hmm.
90,000 and
Yeah.
990,
90.
those will be, sorry, not 9 lakhs, 90,990 are perfect transactions, which is having zero label.
Yeah. Yeah.
Only 10 are having one.
Hmm.
Okay. So same thing. So in this case, the rows with one will have only 10 and remaining will be zeros. This
Hmm.
is an imbalanced data set, obviously. Correct. So for example, if you see just the running topic, so terrorist, if you take, so here also out of total number of people, okay, if you are having
Hmm.
like 1 million population, in that, let's say only 100 terrorists you might have. Very, very small.
Hmm.
But this 100
Mm-hmm.
people can create terror for
Plus
the 100
more.
million.
True. True. True.
Correct. But the count will be very less.
Yeah.
Okay, so in that case, the data set will be false. But here, even though the count is less, identifying those are very important.
Correct.
Correct? Identifying, doing
Yes,
perfect
yes.
is
True.
90,990 is okay, fine. Okay, normal transaction we are detecting. That's perfect. But identifying this 10, that is where the game lies.
True. True. True.
Correct? Same thing. Identifying this terrorist is more very much helpful than identifying whether this person is not a terrorist.
Correct.
Correct? So over here, the problem with accuracy is also that. Okay, that means, for example, if you're having imbalanced data set, like if you see a class A, class B, class A is having like some 9,999 and class B is having very less. Okay, so over here for this class, okay, let's say you're having only 10. Okay, remaining 9,990 went here. Okay.
Mm-hmm. Mm-hmm.
Now, for this class, if it makes error, how many times it will make error? 10 times, because only 10 classes, 10 rows you are having.
Yeah.
Correct? At max. At max, it
Hmm.
makes 10 times. For example, if 10, all 10 it is misclassifying and saying all B classes are also A classes. Okay. That means only 10 times it is making error. Okay.
Correct.
So that means what? 99990 times it is working well.
Yeah.
Okay. By overall 10,000 prediction
Correct.
you do, that means what? 99.9 is accuracy.
Correct.
Correct? Accuracy is
Yeah.
what? So like total by how many times it is perfect.
Total by yes.
Correct
Yes.
predictions.
Hmm.
Okay. So if you see all these are perfectly correct, it is doing correct predictions 9990 by total are these. These 10 you are neglecting. So you got
Hmm.
99.9. By looking at 99.9 accuracy, you might think, okay, the model is wonderful.
Model is working. Yes.
Correct? But
Yeah.
you don't know like where it has went wrong. Okay, this 10
Correct.
has went wrong, but this 10 is the actual crux.
Correct. Correct.
If you want to find out, right? If you are losing this, even if you have 99.99 also, not worth.
The same cancer case. We
Same,
can
same.
because today it is 10,000. There might be chance it might be 1 lakh, 10 lakhs.
Correct,
Percentage will increase. Yes. Yes.
correct, exactly. If you take the whole our Indian population 140 million,
True.
so in that 1 million here 140 million, right? So 139 if it is going here, only 1 million over here. In percentage wise, it is only 1%.
True.
For example, if it is failing for in this 1%, 0.5% also, you might think
Hmm.
okay, 0.5% it is failing, but it is half a million.
Yeah. Yeah.
That means 5 lakhs.
5 lakhs.
5
Yeah.
lakhs people. Correct? So that's why
True.
percentages will sometime mislead us.
True.
Okay. And if you consider this the accuracy here also it will be like 99, 98.
Hmm.
Okay. And if you think, hey, I got 98% accuracy, model is almost perfect. Just 2% it can go wrong, but 98 it is working fine. And if you deploy it, okay, and if you start using that model,
Boom.
people will start dying. Okay,
True.
fine. Okay, because you don't know where it is failing. Okay, that's why I told you where it is working fine, that's fine, but where it is not working fine, that is important.
Yes.
Okay, so only then we can use another model. Okay, so now when you are learning to after
Yeah.
that,
Yeah.
you said you learn SVM, Canaan, right? So now first you use logistic. Okay,
Hmm.
so you will see what are FPFN.
Yeah.
Then you will understand, okay, these are FPFN values, but as my, for example, cancer case, my FN should be low.
Correct.
Then, but if FM is low, but not very low, okay, then you will go to SVM. Again, you will build a model, then you will do this conversion matrix, then you will see FPFN.
Yeah.
Then you will have KNN. Okay, you 3-4 models you will build, then you will pick the model which is having the lowest FN.
True. True.
Correct? So that's where it will help you in the model selection.
Correct. Correct. Got it. Got it.
Yeah, same thing for FN also, FP also. Okay,
Okay.
fine. So now that is the reason why we are not using the accuracy. One is imbalanced data set, it will fail, and second thing is you don't know where exactly it is failing. Okay, fine. So because accuracy is failing,
Mhm.
we need to have new metrics, right? So you are saying okay,
True.
accuracy is failing, that's fine. But next what is going to replace it? Then we have like 3 or 4 metrics, okay, which are very very important metrics. Okay, so those are called as precision, recall, and F1 score. Okay, these is
Okay.
the name of accuracy which you have just studied.
Okay.
Precision, recall, F1 score. These are next fundamental concepts. Okay, based upon these only we will build the metrics.
Okay.
Okay? And what are these? Okay, so these are very nearby concepts. First time when you study, or first time when I studied also, we'll get confused. We'll think, hey, we are studying the both. Why we are studying same thing two times? Okay, but there are fundamentally very different concepts. Okay,
Mhm.
so but we'll understand it from basics. Fine. Any doubts till now?
No.
No, right? Okay, fine. So now this is my confusion matrix. I hope there is no confusion in confusion matrix.
Yes, no.
Okay,
No
so
confusion.
positive, negative, positive, negative. Okay, so you can just you don't worry about this position. You can create your own combination matrix 1 0 1 0. Whatever you, if you're using 1 0 here, use 1 0. Then accordingly you will get the FPF and TPTN. Okay, fine. So first thing is precision, Karthik.
Mhm.
Okay, so precision. What is the definition of precision? This is saying of all positively classified points by model. Obviously, model will only classify, right? Okay. So this
Yes.
is saying of all positively classified, how many of them are actually positive?
Okay.
Okay. So don't get confused. So it is saying of all positively classified, how many of them are actually positive? Okay. Just put
Yeah.
it. Now let's try to read the definition of recall. Then we'll try to understand both at a time. Okay. Now recall is saying of all actual positive from the data set, how many of them are predicted as positive?
Mhm.
Okay. So see what it is saying is precision is saying, see, one fundamental thing is you are sending some data set,
Mhm.
okay, and model is giving some predictions. Okay,
Correct.
that is there. So the model can give, when you are passing one, the model can give 0 or 1.
True.
Fine. So now precision is saying of all the positively classified points by model,
Mm. Mm.
how many of them are actually positive? That means
Okay.
model is predicting X number of data points as positive.
Once. Yes. Okay.
Once. But whether all of them are actually in the ground truth from the data set, how many of them are actually positive? Because even for 0 also the model can give 1 in some cases. Even for 1 also model can give 1. So if I am sending like there are like, let's say 1 1 1 1 0 0 0 0. Okay, or we have this data set, right? So for example, you are having ones and zeros here. Okay,
Yeah.
so you are having 1 1 1 1. Okay, just 0 0 0 0 you are having. Okay, let's say you are having 50. Okay, and this, let's say you are having 40. Now let's say you have passed all these ones to model. Okay, this is your model,
Mhm.
logistic regression or any model, any model. Okay, as I said, this
Yeah.
classification matrix is not dependent to any model. Okay, any model you
Yeah.
can. So you are passing this 50 ones.
Mhm.
Now model is obviously going to give me how many predictions?
Depends.
No, no,
Either
no. I'm not asking
prediction. Yeah.
total.
Okay.
50 you are passing, how
Predictions
many will get?
50. Same 50.
50, right?
Yeah.
50 you are going to get. But in this
Yeah.
50,
Mm.
this could be different combinations. Few could be 1,
Correct.
few could be
Good.
0.
Yeah.
All could be 1, all could be 0.
True.
Same thing also,
True.
you are passing this one zeros.
Yeah.
Okay.
40 we will 40 predictions. Out
40
of those,
predictions.
we are
Okay.
not 4 cases.
Same case. Okay.
Mm. Mm.
But yeah, you can understand with both the cases. But usually, precision and
Mhm.
recall or all these metrics, they take one as example.
Okay. Yes, yes, correct. One as example. Yeah.
That's why they are saying positive class. Okay.
Correct. Correct.
That's why they're saying of all the positive class, recall is saying of the actual positive. Okay. You can take
Yeah.
any also, any which way, anything you will understand. Okay.
Yeah.
After that, when we are seeing about the multi-class, that more than 2 classes, then we'll understand how we can deal with that. Okay.
Sure.
But now
Okay.
here it is saying of all the positively classified model by the model. So out of all the wherever the model is saying 1, rated as 1, in that how many of
Mhm.
them are actually 1?
Mm.
Correct. So model is saying ones. So in that, by default only 10 could be 1, remaining 40 could be zeros actually, but model is saying 1. There could be different combinations. You are getting right?
Yeah. Yeah. Yeah.
Right. So now what is the formula? Out of all the positively classified by the model, okay, see, these are the model predictions. These are
Mm-hmm.
actual. Model is this.
Correct.
Correct.
Model prediction. Yeah.
So in this model, what are positive? These are positive. These both are positive.
Correct.
True positive or false positive?
Yes. Both
But
are
from model
positive only. Yeah.
perspective, those are positive.
Correct.
So out of these two, how many of them are actual positive? What are actual positive?
Positive, positive. TP.
TP, correct? So that means TP by TP plus FP,
Mm-hmm.
correct? So that is a equation of pressure. TP, true positive, TP,
Okay.
correct? By true positive plus false positive, TP plus FP.
Okay. Actual positive by total positives predicted by model.
Correct. Total positively predicted values, in that how many of them are actual positive?
Correct.
TP by, I mean, you can say other way. So actual
Yeah.
positive, not actual positive. Yeah, you can say actual and predicted both. Actual positive
Mm-hmm.
divided by total predicted positive.
Yeah.
Okay, fine. So this data set you can also understand this way. So these are, as I said, these are predicted positives.
Yes.
These are predicted negatives.
Negative.
Correct. And these are actual positives.
This is the
These are
actual
actual
negative.
negatives.
Yeah.
Okay, fine. So pressure is TP by TP plus FP. Usually I remember it like pressure
Yeah.
starting.
P starts with P. That is this is completely true.
Okay, TP by all P's. TP
Mm-hmm.
by TP plus FP. Small.
Mm-hmm.
That's
Yes.
how
Yes.
nice. Okay.
Yes.
Now coming to, yeah. So
Recall.
yeah, we'll see the example. But coming to recall, this is
Mm-hmm.
saying of all actual positive from the data set, how many did the model say positive? Okay, that means of all the actual positive from the data set. What are actual positive from the data set?
TP FN.
TP plus Fn. Okay.
Yeah.
In this, how many of them are actually positive? TP.
TP.
Okay. So that is TP by TP plus Fn. See here,
Got it.
TP by TP plus Fn. Correct.
Yeah.
Here also, TP by these both will give you actual positive from the data set, because true positive is also positive. False
Hmm.
positive is also actually positive.
Yeah. Yeah.
Correct. TP by TP plus Fn. Okay. So this is recall.
Yeah.
Okay. So I hope there is no confusion.
Yeah.
Correct. In precision, you are focusing on the model predictions.
Correct.
Okay. How many did the actual, when I'm saying, yeah, in precision, you're saying the model is predicting this many, but how many of them are actual positive?
Correct.
In recall, you are saying, okay,
Input. We are completely.
yeah. So from my given data set of all the ones, all positives, how many did the model tell us positive?
Yeah.
Okay. I hope you understand this difference clearly.
Yeah. Yeah.
Any doubts you can ask?
Sure. No. No.
No,
It's
right? Okay, clear. So now if you see here, these two are TP by TP, FP, FN, TP. Okay, these are the values. And as you can see, T pressure of one is desired. Okay, the more value of pressure
Mm-hmm.
we have, the better the model.
Okay.
Okay,
Yes. Correct.
why?
Correct.
Why? Because if you see why here, as I said, in these four values, which values we want high values and which values we want low values? Out of these four,
We want high values. TP and TN should be high always.
correct, and FP and FN should
Mm.
be low.
Correct.
Correct. So over here, if you see this formula, FP is in the denominator.
Hmm.
So if you decrease FP, overall value will increase.
True.
Okay. So that means the lower FP will give you higher pressure.
Correct.
Correct. So that's why we want the maximum value that is possible for the pressure. Okay. So
True.
maximum, these are percentages. So if you have 1,
Hmm.
then it will be maximum. Can you just tell me when this value will be equal to 1?
Equal to
1. When pressure when does
if
pressure,
FP is 0,
correct.
then value will be 1.
Perfect. So when FP becomes 0, this will become TP by TP, 1.
Yeah.
That means what? There are no FPs. There are no false positive errors.
Correct.
Correct?
Correct.
Clear. Now coming here, this also we want 1.
Hmm.
Correct? So here also we want the recall should be 1.
FN should be 0.
Over here, but when it will become 1,
FN should be 0.
Fn should be 0.
Yes.
Okay? That means Fn should decrease, then this will all TP by TN. Okay? Perfect. So now can you tell me, in cancer case, which one we want? High pressure or high recall?
High pressure Uh,
consider cancer
hmm,
case.
hmm.
Which value are we looking for? Do we want high pressure or high recall? And also, what before you're answering one thing, again there is a trade-off. Just like just when I said that overall values, for example, overall is 100. So if you increase one
Mhm.
value, other value will decrease. There is a trade-off between these four.
Correct,
Right?
correct,
It will
correct,
be
correct.
distributed.
100, it should be 100%. Yeah.
Yeah. Same thing. That means what? If you are decreasing FP,
FN should be increased.
yeah, FN will increase. Or if both are
Hmm.
decreasing, then some other value is increasing.
Yeah,
Okay.
TPR. Yeah, yeah.
That is increasing. Okay. But
Hmm.
usually if you are having some error, okay. But if
Mhm.
you decrease FP, FN will increase, or FP will increase, or FN will increase. Something.
So in cancer case, FP should increase.
Sorry, in cancer case,
FN should be 0.
correct. That means what? Just
So
tell me which value you want high. Recall high or pressure high.
recall high or pressure high? We want pressure high in that case.
Yeah. If you want
FN should be
pressure,
0, right?
yeah, no, but if you want pressure high, okay, you are saying pressure high. Okay, I'll increase pressure. That means what?
Mhm.
Which if this should be high, what should be low? FP should be low.
Yeah.
If FP should be low, that means indirectly you are saying FN should be high. If
I
F
mean,
if FN is
okay.
high, that means recall will be low. So that means what? FN is high. FN is high means what? FN in cancer case means false negative. That means this guy is not having uh cancer. Okay, but you are saying
No,
cancer.
no.
No,
No, no. FN means reverse. He's not, he's a cancer person, but it's not giving cancer.
yeah, is a cancer person, but not having cancer.
Yeah,
Okay, no is no cancer. Okay, but actually is having cancer. False negative.
correct.
Okay,
Hmm.
yes,
Mm-hmm.
actually is having cancer, but not cancer. So you are saying
Yeah.
these cases. That means the
Mhm.
doctor is saying for a cancer patient is not a cancer patient. That value should be high. You are saying.
FN should be 0 basically. I mean,
Yeah,
should become 0.
correct. So yeah, you are saying correct. So, but what we are saying is FN should be zero. That means what? Recall should be high. If this
Yeah.
FN decreases, recall will increase.
Yes, yes. Okay,
That
got
means
it.
pressure will decrease.
Correct.
Just like
Correct.
how FP, FN have trade-off, recall pressure will also have
Mm-hmm.
trade-off. If recall
Okay,
increases,
okay. Got it. Got it. Got it. If recall is increasing, pressure should be decreasing.
correct? So in cancer
Yeah.
case, recall should be greater than pressure.
Correct. Okay.
Clear?
Clear.
In spam case, what we want
Pressure should be high.
should be
Yeah.
low, right? In where we have in
Correct.
spam
Correct.
case, if you see
It,
FP should be lower than FN.
correct.
Means what? This FP this FP should be low. If this is low, this value will be high.
Pressure should be high.
High.
Yeah.
Correct?
Yeah.
And
So recall will be
this
low.
high, recall will be low. So
Yeah.
pressure will be greater than recall.
Got it.
Okay. So
Yeah.
there is a trade-off between pressure and recall. So basically now you should think that from pressure or recall. Okay. So not
Yeah.
FPFN. So internally it is that, but if given as per the domain, which one I should focus? Is it pressure or recall? You want low pressure, high pressure, low recall, high recall. Clear?
Oh, yeah. So if someone asks like recall should be low, then
Hmm.
I have to focus on I mean recall should low means I have to concentrate on precision.
No. See, if recall should be low means what? What value? When this will become low, false negatives. If it is low, that will become low. Once this
Yeah.
is low, for it, see, low recall means
High
false
negative.
high
High false negative.
are high.
Yeah. So
Okay,
it should not be the case
it should not be the
because
case. That
always
means no.
yeah.
In cancer case, for example, in spam case, we want
Hmm.
what pressure should be greater than recall.
Correct.
Okay, that means what?
No. In
Uh,
cancer case,
spam case, spam case.
yeah. Okay.
Okay, in spam case, I want false positive. For example, if you see in
Correct.
spam
Correct.
case, okay, my false positives should be less than my false negative.
Correct.
My false positive is less than means what? If false positive is less, that means this part is less. This overall part will be more. That means what? Pressure is more.
Mm-hmm.
Clear? My pressure is more means what? My pressure value should be greater than my recall value.
Correct.
Right? So that means what? This value is greater than this value. Correct? That means what?
Yeah.
This recall value we are reducing. Only then
Yeah.
pressure value will increase.
Correct.
if recall value is reducing, when this will reduce, only this Fn will increase.
Fn should be increased. Yeah, in spam
Correct?
case. So
In
we
spam
have to
case.
calculate both, and we have to check which one
Correct.
is greater than, which one is less than. In such a way, okay, got it. Now
Correct.
clear.
Correct. So now you will take three models: logistic regression,
Correct.
precision, recall.
Yeah.
Precision, recall. Decision trees, precision, recall. So which model is giving you less precision or more precision or less recall as per your case?
Depends upon case. Yeah, got it.
Clear?
Understood. Yeah, clear.
Okay, fine. So same thing. For example, if you see here in the precision case, so I'm saying these two models are there, right? So
Mm-hmm.
can you, this is spam, this is not spam. Okay. If
Hmm.
it is spam, I'm saying true, okay, or one, and it is zero. Okay,
Yeah.
positive and negative. Okay. I'll go positive. Yeah, positive, negative. And this is spam, not spam is negative.
Mm-hmm.
Okay. TP, TN,
Yeah.
and what is this? FN,
Opposite Fn and FP.
FP. Okay. Same thing for this also. So this is model A, this is model B.
Okay.
Okay. Two models you have developed.
Okay.
Now, can you just tell me based upon these two models, but the values are different. You see 100, 170, 30,
Yeah.
so
Yeah.
190,
Yeah.
10.
Hmm.
One important, can you just tell me which model can we deploy for the spam? But before that, if you see, if you calculate the accuracy, what is the accuracy for this model? TP
Should be
plus TP.
100%. Yeah, 800 by 200.
Why 200?
No. Complete. Sorry.
Yeah. How much it is? 7, 8, 900. 9,
Hmm.
10, 1,000.
1000. 80%.
80%. Okay. Can you tell me for B?
These also like total 800 by 800. 1000. Same 80%.
Correct. So now this is one more example. So if you see accuracy, both are 80%.
Correct.
Correct. And if you think
Both are 80%.
if you select randomly one, then that is wrong.
True.
So that's why you will go one step lower. Okay.
Okay.
One step deeper. Now,
Yeah.
can you just tell me for this spam case, which model is okay to deploy?
Uh, in basically spam, uh, FP should be, sorry. Yeah.
Or forget about this FP. Just tell me, you see these values, not spam, 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 not spam, you're saying, right? Based upon
Mm-hmm.
this, just tell me which value should be low and which model is having low value.
Not spam going to not spam is going into spam. Yeah. Second model B.
B.
Hmm.
This one. Why?
Yeah. I mean, not spam or going into spam are 10. But the first one, not spam, going into spam are 30, and the spam going into one second. Spam. Yeah, not spam going into spam are 30. That is the dangerous case.
Correct.
Hmm.
Okay. This is not spam. 30 or not spam, but they went into spam.
Yeah.
Correct. Here,
Hmm.
only 10 or not spam. Okay.
Correct. Hmm.
Clear? So in this
Correct.
case, B is better. Okay.
Hmm.
That is what this is FP, right?
Yeah.
So FP should be low.
Correct. FP should be low. Yes.
Same thing here also we have seen in the spam case, FP should be lower than FN.
Yeah.
Okay. So
Hmm.
now here, accuracy, this is the part. Okay.
Hmm.
Now, can you just tell me, let's calculate precision. What is precision? TP by
TP
TP
by
plus what precision, sorry, TP by TP plus FP.
hmm
Okay. Can you tell me what is TP?
total positive 100. True positive.
By what is TP plus FP?
110.
110 for this case, for this.
Oh, okay. Sorry. First one. So 100 by 130.
Okay. And this is for precision of A.
Yeah.
Now,
A
what is
model. Yeah.
precision of B?
100 by 110.
100 by
110.
110. Okay. Which value will be lower?
Lower one. P value should be lower because the denominator is more.
Yeah, which will be lower in both of this? Which value will be lower? Where the denominator is higher, right?
Yeah, that's why PA is lower.
Correct. Yeah. So here B is lower, so this will be high value. Okay.
Yeah,
So
correct.
PB, okay, pressure of B is greater than pressure of A.
Yeah,
Correct. So
correct.
and we want pressure should be more. Correct. In the spam case, if you see, pressure should be more.
Correct.
Recall.
Correct.
Okay. And here you can also calculate recall. Recall, if you see for this case, what is recall? TP by TP plus FN.
Yeah.
Okay. So for example, if you see recall of A, recall of A is what? TP 100
Yeah.
by TP plus FN. TP FN 800. Correct? Oh,
Yeah.
sorry.
No.
TP
100 by
FN 270.
270.
And
So R is
recall of B
also
100 by
100, 290.
290.
Yeah.
Okay.
Mm-hmm.
So I'll just do this value. So this is 100 by 130.
Mm-hmm.
Okay. 76.9.
Mm-hmm.
Okay. This is pressure of A. And 100 by 110, 90.9.
Mm-hmm.
This is the pressure A, B.
Mm.
And recall 100 by 270,
270,
37.
37.
37 for A. And this is
100 by 290.
290, 34.4.
34. So in spam case, pressure should be greater
Yeah.
than
In
recall.
PAM case, pressure should be greater than recall.
Mm-hmm.
But if you see,
Yeah, first you can B is greater than.
yeah, no, yeah, correct. So this is pressure, this is recall,
First you.
right?
Yeah.
If you see
Mm-hmm.
individually, in both the cases, pressure is greater than recall,
Correct.
correct? But which is having more, which is more better than the because this is 90-34. Okay, see here pressure and recall here also in first model also pressure of A, this is recall of A.
Correct.
So pressure of A is greater than recall of A. That is correct.
So in both cases, it is
Pressure of
giving.
A is greater
Yeah.
than recall of B. Pressure of B is
Correct.
greater than recall of B. That is also correct. Okay, but uh, whatever the requirement we want for spam, that is getting satisfied. But now in these two models, which you want more, because which is having the more pressure. Here,
Okay. Got it.
correct?
So both models are giving pressure is greater than recall.
Correct.
Okay. In, and next case, in both cases, out of both cases, like B model is giving more precision.
More pressure.
Yeah,
Correct. So this is giving more pressure.
got it.
Okay.
Yeah, clear.
Fine. So that's how, yeah, you can check it out. Okay. And but basic concept is you will, as per the domain, if you know the domain, then you will know which type of error you can make. From that, you will understand what are FP and FN values. And once you know
Yeah,
FN values, all these are all chain related, as you can see. Okay.
true.
FP, FN, you will understand confusion matrix. From there, you will understand precision, recall, and which one you can consider or which one you should not consider. Okay. And same thing, you will go for cancer also. Okay. This you can I'm not doing this calculation, but you can understand, right? Also, you
Yes.
can just do this. And here you want recall should be greater than pressure.
Precision. Hmm.
Okay. And for example, here you are saying this is no cancer, but you are having this is cancer. Okay.
Correct.
And which is more dangerous where you are having cancer, but which saying not a cancer. Okay. This is 200.
Yeah,
And here it is 500. Okay. This number is dangerous and it should be low.
correct.
Correct. And so here it is low. That means FN should be low.
Low.
That's why you will choose model A.
Yeah,
Okay. So again, same thing. If FN is low, that means this FN is low. If this is low, recall will be high.
yeah,
If recall is high, automatically pressure will be low.
correct.
That's why R will be greater than P.
Hmm.
Okay, so you choose this. Clear?
Yeah.
Okay. So yeah, so note that we have a trade-off between pressure and recall. Okay, that means pressure and recall if one increases, decreases. But one more thing here is, in some cases, we might not clearly decide
Mm-hmm.
which is more important.
Okay. Okay.
You know the domain, that's okay. But in
Mm.
some cases, it might be difficult.
Mm-hmm.
It's like type 1 or type 2, which is more important.
Okay.
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 That means if that means if the values are very close, for example, if
Yeah. Yeah. Got it. Got it.
Fn is if it is making like 48, and for example, if Fp is doing very near like 45 or something. Okay. If they're very close, like which one can we give more importance? Okay. If you're
Yeah.
not the domain, might be difficult. Okay.
Yeah.
In that scenarios, we have something called as F1 score.
Okay.
Okay? F1 score is not a new concept, which is very related to pressure and recall. It is just clubbing these two, we created a new. Okay.
Okay. Okay.
What is that? Just 2 times pressure into recall by pressure plus recall. That's it.
Okay.
Okay. That means 2 PR by P plus R, we say.
Okay.
PR by P plus R. This is also
Mm-hmm.
called as
Mm-hmm.
harmonic mean.
Okay.
So that means what usually we have different kinds of means. Okay. So for example, uh, means you have, right? So average values.
Yeah. Yeah. Yeah.
Okay. So different types of means,
In
uh,
stats.
like arithmetic. Yeah, you have you have arithmetic mean, you have
Yeah. Geometric mean. Yeah. Harmonic mean. Yeah.
you have geometric mean also. So in arithmetic mean, you will just add everything and by n, that is just average.
Hmm.
Here you will do the nth root of product.
Correct. Correct.
Here, what you are doing is here you will see the reciprocal of the arithmetic mean of the reciprocals of the values.
Yeah.
Okay,
Yeah. 1/HM. Yeah. Yeah.
one
Come.
by okay.
Yes.
So if you do that, what is that? N by 1 by
One by.
that. Okay,
Yes.
that means
Yeah.
n
Got it.
is how many numbers you're having, like 2 by 1 by P
Hmm.
plus 1 by
One
R.
by R.
So this will become
Two.
2 by
Two R. Two PR. Yeah.
P plus R by PR.
Hmm. PR will go up.
This will go up. So that will become 2 PR by P plus R.
Got it.
That is harmonic mean. Okay.
Hmm.
So that means when you not sure which one to take, so we will use both in this mean. 2 PR by P plus R. And
Mm-hmm.
to calculate this simple, first you need to everything starts from confusion matrix. Use confusion
Hmm.
matrix, get these values. From these values, you will get pressure and recall. From that, you will get the F1 score.
So what? So if you get F1 value, then what is the use? Just we'll get the value. Then that is a prediction point
Yeah.
or
Yeah. If you're having 3, 4 models, so which F1 score is more,
higher,
that
then we'll
you
consider.
will consider.
Okay, okay, got it, got it.
Okay. So three, and also this is also not only for different models, Karthik. Okay. So for
Mm-hmm.
hyperparameters also, yesterday when I was saying,
Yeah, yeah, that is respective to the each model
correct.
because model to model hyperparameters might change.
Correct. So when I was saying in
Hmm.
hyperparameters, for example, here you took L2 penalty
Yeah,
and penalty. So that means the line that is getting created by this is different from the line that is getting created.
correct, correct. Another model. Yeah.
Correct. So here the losses will be different. Here the basically the confusion matrix TP, TN, FP, FN values will be a bit different from this. So obviously
Yeah.
the pressure and recall will be different. Here pressure and recall will be different. So the
Correct.
F1 score will be different. F1 score will be different.
Mm-hmm.
So in these two models, so these, as I said, when you change a set of hyperparameters, it will create two types of kind of
Correct.
models, versions.
Correct.
Okay. So there also you can, for using this, you can say which F1 score is better.
Okay.
Okay. Or completely different models you can go for logistic regression, SVM, and decision trees. Here also you can,
Hmm.
it's just a model. You can do
Okay.
this, or in logistic regression itself, you can use a logistic regression 1, LR1, LR2, or SVM also you can change hyperparameters, so SVM1, SVM2, decision tree 1, decision tree 2. Like, you know, you have 6 models you are having.
Okay. So
Then,
those matrix will independent of everything, or those matrix are respective to the classification.
yeah, classification. Yeah, see this matrix, how you are getting this, where is this? This matrix, how, what is this value? TNTP, correct
Correct.
predictions and wrong predictions.
Correct.
When you are doing this, when you are, where is, yeah, so when you are change from first linear regression model and second linear regression model. That means here you are using L1, here using L2. That means here the line is a bit different. Here this line could be something different. Correct?
Correct.
That
Hmm.
means this will make some other errors. This will make some other
Correct.
errors. So
Correct.
these four values, TP, TN, FP, FN have changed.
Hmm.
If these values are getting changed, that's it. Everything will change. So the confusion matrix is different now.
Hmm.
Values are different. If these values
Hmm.
are different, then pressure is different.
Correct.
Because these values are all these are just maths, right? Values are changing, pressure will
Correct. Correct.
recall will change, F1 will change.
Yeah.
It's a different model. Same thing. So SVM to everything, you are having different models. So if you change these values, this matrix will change.
Okay.
But I don't understand your question. So, but the matrix, whatever using, right? See, here your actual.
No, no, no. I'm not talking about this.
Okay. Which
In
matrix?
general, we have these metrics, right? Classification metrics.
Uh-huh.
Earlier also we have seen like after linear regression, we have seen some metrics.
Correct.
Okay, R1,
R square,
such kind,
R
right?
square.
R square, yeah, yeah. So those are respective to only linear regression for
No, no, any regression model. That's what I'm saying.
any regression, and this is for any classification.
Correct. Exactly.
Only for classification,
Only
because
for
of
classification.
zeros and ones will be only in classifications.
Correct.
I
Not only
mean,
zeros
yeah,
and ones, classes.
yeah, classes,
Because,
yeah, yeah,
because for
classes.
example, in the iris data
Multi-class,
set,
yeah,
you're
yeah,
having
multi-class.
three classes, Setosa, Vesicana, Vesicle, or something, right?
Correct.
But those
Yeah, yeah.
we are encoding into 0, 1, 2.
Correct, correct. So, but respective to only classification
Only
models.
classification, correct. Because only
Okay.
in classification, only then you can say true positive, true negative,
Yes,
right?
yes, yes, yes.
In linear regression, the
Yeah.
output is what is the output? Output is, for example, house price prediction. The output could be like 50 lakhs, 70 lakhs.
Correct, correct,
From that, how
correct.
can you say? You can only say
True.
how far it is. The actual value is 70 lakhs. The model is saying 50 lakhs. This much is the error.
Correct.
Okay. But whether it is positive side, but that means whether it is more than this, less than this, that we are not caring.
Correct, correct.
Because we are
Correct.
summing, if you remember, we are squaring this.
Yeah.
Whether the error, we are squaring that error, and RMSE, root means square error.
Correct.
Correct?
Yes.
Whether it is up or down, we are just squaring, right? So we are
Yes.
squaring error. See this one.
Mm-hmm.
These are the error. Whether it is up or down, we are squaring D1 square, D2 square, because we just want
True,
the
true.
number.
Correct.
How far? But
Mm.
here, when it comes to classification, we want which, if it is wrongly classifying, for example,
Yeah.
a person vote, I got to know that this person did not vote to Congress. That's
Mm.
fine. But to which person did he vote? BJP,
Correct.
BRS, Aam Aadmi. So there,
Mm.
or FP or FN, we want all those details. And this is valid only for classification purpose. Any
Got it,
classification
sir.
model, any
Okay, classification.
classification model, but only
Okay.
classification. The output should be in
Okay.
classes.
Okay.
Okay,
Hmm.
clear?
Yeah.
So this is, yeah. So as I said, once you create different types of models, so these values, mainly precision, recall, F1 score, that will be very, very helpful for you to understand how well your model is performing or where it is failing.
Yeah.
Okay.
Hmm.
And coming to F1 score, I was just saying, yeah. So 2 PR by P plus R. Okay.
Yeah, yeah. That is, yeah.
Correct. So basically, what we are doing over here is we get the values of precision and recall for all the individual classes like positive and negative. Okay. This is regarding the multi-class prediction. Okay. Yeah. That.
Mm-hmm.
See. Uh, okay. And fine. I would say that's regarding the uh, F1 score, I would say. Okay.
Mm-hmm.
And
Mm-hmm.
have a practical example
Mm-hmm.
that we'll see in tomorrow class. Okay.
Sure.
Practical
Yeah.
example. And then we will also see how we can do it for multi-class. That means
Okay.
when the classes are more
Mm.
than two,
More than one time.
like you have in Iris, right? So 3 classes.
Yeah.
There, how it will do it. Okay. So that we will see. And how then in that case, how you will get precision values, recall values, F1 values.
Okay.
Yeah. But I would say that is regarding the basics of the conversion matrix. Okay. I hope you understood.
Mm.
First, we started with accuracy. We understood why it is failing. And next, we understood the basic of conversion matrix. And then TP, TN, FP, FN values. From there, we just derived these values. Precision values, recall values, and F1 score values. Okay. Precision,
Yeah.
TP, FP. See, one trick I'll tell you, TN value is there, right? Usually
Hmm.
this only in accuracy. Okay, you will not see TN over here and here. Usually
Correct, correct,
TP by, if it is precision, TP by TP plus FP. Okay,
correct,
all P's, and only change between precision and recall is instead of FP, here it is FN.
correct.
Okay, remaining at TP. Okay, usually people get confused. Okay, so once you have TP and R values, then F1 score is just 2 PR by P plus R.
Yeah.
Okay, fine. So in tomorrow's class, we'll see the practical implementation of how you can get these values, okay, and analyze. And then we will also see multi-class variables. That means if you're having more than two variables, how you can calculate the same thing. And then finally, you have something called as two concepts. One is ROC curve, and finally, you have something called as AUC curve. Okay.
Okay.
These, yeah, when you are studying this, right? So these are mainly related to the logistic regression part. Okay.
Hmm.
So then you will understand few concepts which we studied earlier. Okay. So these are bit separate concepts. Okay. These are also classification metrics only. Okay. But
Okay.
very well related to logistic regression part. Okay. That we'll see. But mainly we will see implementation of these. Okay.
Sure. Okay.
Yeah. I hope you understood. Okay. Any doubts?
No, fine.
Okay. Chalo. Bye.
Thanks. Bye.